Students, in lesson 1.5 Algebra, we will be studying multiplication patterns. Our basic essential question for this lesson is, how can you use a basic fact and a pattern to multiply by a two-digit number? So we're going to start with the unlock the problem. It says, how close do you have to be to, how close, okay, so it says, how close have you been to a bumblebee? Even sometimes teachers too have to reread the questions. The actual length of a queen bumblebee is about 20 milliliters. The photograph shows part of a bee under a microscope at 10 times its actual size. Now this connects back to the first lesson that we did by saying that each time we move to the left of the place value, it grows times 10. It says, what would the length of the bee appear to be at a magnification of 300 times its actual size? So magnification, boys and girls, comes from the word magnify. So when you magnify it, as you can see in this image here on the right, it becomes enlarged, although that is not how big it is in real life. So what we're going to use is a basic fact and pattern to multiply 300 times 200. So 3 times 2 is 6, and that's our basic fact. And now we're going to add a 0 to the 3, and we have 30 times 2. So what we have is really, again, our basic fact, 3 times 2 in parentheses times the first power of 10, which is 60. Next, we have 300 times 2. 300 times 2 is really the basic fact of parentheses 3 times 2 and parentheses times the second power of 10, because we know that there is 100 represented in there, so that is 10 times 10. 10 times 10 is 100, and 100 times 6 is 600. Next, we have the problem that we in fact wanted to solve at the beginning. So we have 300 times 20, which is the basic fact of parentheses 3 times 2 times 10 times 100. And the reason why we have 100 here and 10 here, because we're representing the 100 and the 10 that are inside of 300 and 20. So we do our basic fact of 3 times 2 and we get 6, and we know that 100 times 10 is really the third power of 10, which is like saying 10 times 10 times 10, which is, I'm going to write that down on the side just to remind ourselves, 10 times 10 times 10, which is 1,000, and 6 times 1,000 would give us 6,000. So the length of the bee would appear to be about 6,000 milliliters. Now in class we're going to do this math talk, but I'm going to read it just because I want you to start thinking about it for this lesson. It says, generalize. What pattern do you see in the number sentences and in the exponents? So first we have the number sentences and then the exponents. Number sentence, then the exponent. Number sentence, then the exponents. Next, it says, what would the length of the bee shown in the photograph appear to be if the microscope shows at 10 times its actual size? Well, if it shows at 10 times its actual size, what we would do is we would take the actual size of the bumblebee, which is 20 milliliters. Not milliliters, millimeters. Sorry, boys and girls. And what we would do is we would multiply that by the magnification, which would be 10 times its size. So our basic fact here would be 2 times 1, but we're going to expand that. We're going to say 20 times 1, which is really like the basic fact of 2 times 1 times the first power of 10. And we would get 20 as our answer for this. Then we would expand it further to be 20 times 10, which is equal to the basic fact of 2 times 1 and parentheses times the second power of 10. When we evaluate the second power of 10, we really know it's 10 times 10 times 2, which comes from 2 times 1. So 10 times 10 is 100. 100 times 2 is 200. So that's applying the strategy that we just used. So we know that in that particular example, it would appear as though it is 200 millimeters large. Next, we have another example where it's asking us to use mental math in a pattern. So what it wants us to do is multiply 500 times 800, and we can pull out from that basic fact 5 times 8. So that's where we're going to start. 5 times 8 is 40, so what we're going to do is we're going to add on to that basic fact. So 5 times 80, the basic fact is, again, 5 times 8, and parentheses, times the first power of 10, because we know that we're talking about 8 tens, not just 8 ones. When we evaluate that, we get 10 times 40, which is how we come up with the 400. I'm going to write that out a little bit clearer so everyone can see that. And that's how we get back to the 400. Next, we expand that further out, and we say 5 times 800, and we get parentheses 5 times 8 and parentheses, and we would get from that again 40 times the second power of 10, which is like saying 10 times 10 times 10. So we count our zeros. We know our answer in this case would be 4,000, because there's a 0 from this 10, a 0 from this 10, and a 0 from this 40. Next, we'd expand our pattern out to be 50 times 800. The basic fact again, 5 times 8 and parentheses times 10, and that 10 comes directly from the 50, and then we would say times 100, which comes from the 8. So another way to express this with exponents would be saying the third power of 10, which we know is the same as saying 10 times 10 times 10. And we multiply that by 40, and we would get the answer of 40,000. Because remember, we're picking up zeros in this pattern. 1 0 here, 2 0 here, 3 0 here, and a fourth 0 from 40,000. Finally, we get to our actual problem, which is 50 times 8,000. We use our basic fact of parentheses, 5 times 8 and parentheses, and then we multiply that by 10 times 1,000, because we know that there are actually more sets of 1,000s in there. There's not just one, there's actually more than that. So really what we're saying is we have the fourth power of 10, which is like saying 10 times 10 times 10, or we can represent it as 1,000 times 10 times 40. So we're picking up our zeros and counting the pattern. We would have 1, 2, 3, 4, and then we would have a fifth 0 from the product of the basic fact 5 times 8. So in this example, our answer would be 400,000. Now throughout this lesson, students, remember, if you're starting with a basic fact pattern and then you're expanding out and applying the principles that we learned with exponents and powers of 10, make sure that you're practicing your powers of 10, and I'm just going to write them out just to kind of have people remembering them. So the the 0 power of 10 is 1. The first power of 10 is 10. The second power of 10 is 100. And the third power of 10 is 1,000. And again, this is because of how it translates. 10 times 1 is equal to 10. 10 times 10 is equal to 100. And 10 times 10 times 10 is equal to 1,000. Make sure you take really good notes with this lesson.